So I'm going to type in charges and fields PhET, P-H-E-T, into Google, and it's the first thing that comes up. And this is a Chromebook. This works on Chromebooks because this is in HTML5. So you'll see that I can pull out positive charges, and it creates a representation of electric field there using arrows. Now my only problem with those arrows is that those arrows are not longer for stronger electric field. Instead they are more white. So the whiter or brighter the arrows are, the stronger the electric field. But it gives the idea, at least, of a vector field diagram. Now you can turn that off, and instead you can put out these little yellow things called sensors. And wherever you put a sensor, you'll see that it tells me the direction and strength of the electric field, the strength from the length, and the direction from the direction of the arrow. So the blue is a negative, and the reds are positive. So I can do that. Another thing I can do is I can come over, and on the right-hand side, you can grab this little voltage measurer, and I don't think you can see it there, but it actually has the electric potential displayed on it as a number of volts. So what I can even do is I can find 0 volts, and then I can push this pencil, and it draws an equipotential, or an ISO line, I guess what they're going to call it on the AP Physics 2 exam. So now I'm going to find maybe 4 volts and draw that one. Then maybe I can find 20 volts, and I can draw that one. And I'll just do 10 volts just for the heck of it. Alright, that's enough ISO lines in my opinion. So I'll put this back where it belongs, put it back in its box. And when I turn on electric field, then the students can see that electric field always points perpendicular to the ISO lines of potential, and electric field always points downhill toward lower potentials. We have 20, 10, 4, 0 volts. Electric field always points downhill to lower potential. Now, I also have an arrangement on this other screen here. So what I've done, this is another setup here. I've turned on the grid, as you can see right here, and I've put all these little electric field sensors everywhere at different grid points. So I turn on the grid and I can see the electric field sensors. And then what I can do is I can put out maybe a positive here, and put out a, no, maybe a negative here. Yeah, I'll just put out another positive for the heck of it. And so your students can now see more of what a real electric field vector diagram looks like, because they can see the longer arrows for the stronger electric field. So electric field is stronger, closer to the charge, and electric field is closer, stronger to the negative charge. But at the same time, these long arrows are kind of ugly. They make the diagram not look very good. So on a real electric field vector diagram, and you can show them some, these long arrows that cross into other arrows' sort of personal space, they are eliminated from the diagram. And then we can take this potential contour creator, and let me just do, say, 10. Okay, so I'm just going to do 10 and 11. And so what am I doing? I'm just finding different potentials, 10, 11, 12, let's just say for the heck of it. Okay, so it's a little difficult to do on the touchpad for the mouse. So what do we see there? All those have a potential difference of 1 volt. Those 10, 11, 12, that's a potential difference. Now let me come out here into the area in between charges, or maybe just up here where we have short electric field vectors. So here's 5. Here's 4. Find 4. So find a volts for 4. Here we go. Okay. And then we're going to find a volts for 3. We'll find 3 volts. We eventually will. I'm pretty sure we will. Especially since I'm below 3 right now. So I just have to scooch until I find it. Okay. So what do I want students to take from this? When the electric field is strong, the difference of the different potentials are very close together. In other words, it's a very short distance between 10, 11, 12, 1 volt away. So the contours are close together, and that's a steep slope of electric potential. But when the electric field's weak, that's a small arrow, then the potential iso lines are far apart. That's not a steep slope. That's a very shallow slope of electric potential. So what I would do is I would have students play a little around with this, especially if you have access to Chromebooks or really anything in your classroom. Anything should be able to run this because it's an HTML5, and just have them try different arrangements of charges, have them draw the fields and potentials, and then have them draw conclusions about the relationship between electric field direction and the potential contours, the strength of electric field and how close the contours are together, and things like that.